All right, so today we are going to talk about the cross product. So, in case you aren't familiar, the cross product is almost like a multiplication sort of thing that we do with two vectors, not just normal numbers. And the answer we'll get from the cross product will also be a vector, which is why we also sometimes, some people will call it the vector product, but we're going to call it the cross product here. And we'll just start off with an example here. How about let's call this vector, let's say it's vector A, and we'll say it's got the points 3, 1, 0 in three-dimensional space. Really, it's just sitting on the XY plane because there's a 0 in that Z, but you'll see for a vector, the vector result of a cross product will need this third dimension, as we talked about previously. So we're going to draw the coordinate axis out here. I'm going to ignore the third dimension for now because we're just working in 2 dimensions currently. But so our vector A we'll keep in purple here. I like to keep things color-coded to keep them a little bit more clear. But a vector, all it is really is an arrow from the origin to the point 3, 1, 0. That's an oversimplification of vectors, but for the cross product, that's really all we need to think of it as right now. We have this vector, this arrow that points to 3, 1, and 0. And once we get this in here too, zoom in a little bit so we can, makes it a little bit easier to draw these. I like to use the shapes, keep everything to scale as best as I can, so our vector, the drawing of the vector results here will actually, it's mostly to scale. It'll make some sense here. And let's take a cross product of this vector A cross vector B. We'll do this in yellow. And that's -2, 3, and 0. So again, on the XY plane, we're still kind of ignoring this third direction. It's just to make things easier here when we see what happens with the resultant vector that we're going to get. But suffice it to say, it's going to be in that third dimension. But we'll see how we get to that. There's a few different ways we can get to that. This part of the video, we're going to specifically talk about the determinant form and how we can use that to get the cross product out of 2 vectors. All right. So determinant form is just, we're sort of taking a matrix. We're making a 3x3 matrix for determinants don't have to be 3x3 matrices. They're actually easier to be 2x2 matrices. And they can be all sorts of kinds, but we're sticking with this 3x3 matrix because on the top row, we're going to have the unit vectors, the basis vectors, I hat, j hat, and k hat. And those just are unit vectors. I'm not going to draw them on our coordinate axes, but they run right along with the x, y, and z axis. And I keep them color-coded too, so I'm not going to draw those basis vectors. But that's what I hat, j hat, and k hat represent. We have those, and there's the z-axis now, because you'll see when we get the resultant vector, we're going to need this third dimension now. That's why I've included the zeros at all to begin with. But these middle row here, we're going to write in, across the row, we're going to write in the 3 parts of the 3 components to the A vector. And that was, again, 3, 1, and 0. We'll do the same in the last row for the B vector, and that was -2, 3, and 0. And so now, when using the determinant form to compute your cross product, there's 3 main steps, and we're going to get each component of the resultant vector, I hat, j hat, and k hat. For this first component, the I hat part, we're going to look at this square here, this 2x2 square that I'm drawing in this dotted red line. And as you notice, it's the part of the matrix that isn't underneath the I. You ignore that column, and you go to the other square out next to the column. And there's a kind of a particular order that has to go about when you do this to take the cross product. It's a little confusing, so bear with me, but when you do it enough times, you'll get it. You'll remember it. But this is kind of, in my mind, where the cross comes from, is we have the square now, right? So we're going to take this 1 up in the top left corner, and we're going to multiply it with the 0 down here in the bottom right corner here. And so we sort of make this diagonal from the purple 1 to the yellow 0 down there. And then we're going to subtract that with, we're always starting with purple first, the purple 0 up in the top right corner, and we're going to cross down, make a diagonal down to that yellow 3 in the bottom left corner. And so those two products are going to be subtracted from each other. And you see I drew in the little gray cross there. In my mind, this is what I think of when I think of a cross product. And so I really do like the determinate form to find a cross product. But so we have that, and as in this case, it's very simple. It's just 0 minus 0 is going to be 0 I hat. And so that's our I hat component. Now we're going to move on to finding our J hat component. This is going to be really similar. You don't even necessarily always have to redraw the matrix like I'm doing. I'm doing this to keep things a little clean, but you can work with the same one. You don't have to draw these boxes, but I'll show you here. Again, we're going to same thought process. It won't be a neat square this time, but the two parts of the column under that aren't underneath J hat, those are the two parts we're going to be multiplying together and taking a difference of for this cross product. And so I'll draw the gray cross like X in here again. That again, to me, is like a perfect visual representation of the cross product. That's how it really sticks in my head thinking of it this way. And again, this order matters. You're starting with the top left corner to the bottom right corner, and then you start with the top right to the bottom left in that same order. And it's the key is important here because we're putting a negative sign. I don't know, I snuck it in there. I don't know if you noticed this, but for the middle term here, for this J hat term, this middle term has a negative in front of your entire result here. So that's the key part too. You got to remember to get that negative in there. Keep the order with the cross the same, throw the negative in there. If you're working in more than 3 dimensions, every other dimension will be a negative in front of it, but we're just in 3, so we got a positive, a negative, and a positive. And as you can see, it turns up to just be a negative 0 J hat, so we still got 0 and 0. And we'll move on here to our final direction, the K hat direction, and this is where it gets interesting. We have the resultant of our two A and B vectors lived right on the XY plane. We didn't need the Z direction to describe them at all. But so far our cross product has no components in the X and Y plane at all. But when we have the same thought process here, we're going to multiply this like box that's not underneath the K hat, and as you notice, now our zeros are gone. So when we take this cross product, we're going to go our purple 3 cross down to the yellow 3, that's 3 times 3, and we're going to take the difference of that with, again, start with purple up in the top right, cross down to the bottom left, and that's 1 times a negative 2, and that's going to give us a 9 minus a negative 2, which will be a positive 11 in the K hat direction, even though our first 2 vectors had no components in the K hat direction. And now that's an important point about the cross product, because this will always be true. Your cross product, what this means is your cross product will always be orthogonal is the official word for it, but at a 90-degree angle or perpendicular to both of your first 2 vectors. I kept it simple. I lined up our first two vectors so they sat right on that XY plane. But they don't have to. They could have a Z component. You can always find some plane. It just won't be as neat sitting right on there, but you can make that plane and your cross product will be perpendicular to that. Oh, it'll always be perpendicular to that. And again, if it's simple, if you keep it right on the XY plane, the only way for it to be perpendicular to both vectors is to be right along that Z axis. It has no components in X or Y. It only has components in the Z axis. And so I'll draw this up here. I'll show you the result, because you can draw this resultant as a vector on its own. It is its own vector too, is the fun thing. So we'll say A cross B equals the resultant vector C. And we can represent C, I'll draw it in orange, and that's the vector 0, 0, 11, as we saw earlier. And so we can draw this same arrow on the same coordinate axis, and this is why we need this 3rd dimension now. And it will just run right along the Z-axis, and I don't really have 11 dashes, so I'm just going to drag it out as far as I can. And again, it would be sitting actually right on top of that Z-axis, but I want to really make sure I'm not going to totally cover up the Z-axis, because I want it to be important to know that this is 3 dimensions. This isn't a diagonal line. This is a 3rd dimension coming out of the page towards us. So yeah, that would be, and this was the determinant form to finding the cross product of two vectors. And it's, again, my favorite way to find the cross product, and we'll move on to the next way.